The radius of convergence of the power series, this is, we have to find a radius of convergence of power series. So this is a series, and if this is positive term series, we can apply many tests to check it is convergent or not. So one of them is very popular and common, which we use to test the convergence of the series: root test and ratio test. These are frequently tests we use. So if you are going to check if this is for what values of x this series is convergent, so you can apply root test, ratio test or root test, any one of them. Many cases root test is helpful whenever it is not of the power 1 upon n or n type. Root test is very helpful in this case. So we are going to apply a root test, and this is the series, power series. Suppose this is an, and x minus a raised to the power n. This is power series around the point A. If you are going to find radius of convergence, so you need to take only an and apply ratio test, means radius of convergence for this series will be an upon an plus 1, and take modulus, because terms of this series may be positive or negative, so apply root. Also radius always positive value, so we took mod of this. So this will give you direct radius of convergence of power series around a point A. But you can proceed entirely. Suppose this is your Cn, then you can find limit n tends to infinity un, sorry, Cn. If I use Cn upon Cn plus 1, and this you will find a limiting value L, suppose. So for what value this will converge, means if this limit is greater than 1, so this limit involve terms of x, because when we apply n tends to infinity and Cn involve terms containing x, so this limit will be expression or terms having x. So you can take x outside, and because that was free from n, so you can take outside, and you will have like this. Suppose 1 upon 4 x plus 2, this is your L. So this will converge. Suppose this is x plus 2, it will converge when it will greater than, and diverge for less than. So from this point you can say that at x plus 2 is less than, sorry, greater than 1 upon 4, or minus 4, sorry, less than 1 upon 4. So that will be your radius of convergence. So there is no confusion. We are going to apply direct formula as to find the radius of convergence of this power series. So r equal to an upon an plus 1. This is a direct format. So we are going to take limit n tends to infinity. So limit n tends to infinity. An is minus 4 raised to the power n divided by n plus 1. And an plus 1 will be minus 4 raised to the power n plus 1. And in denominator, n plus 1, n plus 2. That will be equal to limit n tends to infinity. This will go above. So 1 upon 4 n plus 1 n plus 2 divided by n plus 1. So this is of the form 1 upon 4, and you can take from numerator and denominator n square as a common. So n square 1 plus 1 upon n, and in second bracket 1 plus 2 upon n. Similarly, from denominator n square, it will be 1 plus 1 upon n. This will cancel out, and after taking the limit n tends to infinity, all brackets will goes to 1. So this is 1 upon 4. So radius of convergence r is 1 upon 4 for this power series.